Hi, in this video I'll show you how to use the methods of graph transformations that you've learned in algebra or pre-calc to solve this problem of writing the equation after you've reflected y equals e to the x across the line y equals 7. In pre-calc and algebra, you learn about reflecting across the x-axis or the y-axis, but not reflecting across a different line. So first, let's review the rules of graph transformation. When you have adding and subtracting some number, that indicates a shift. It's either a shift up or down along the y-axis, or the shift right or left along the x-axis. The way it was taught in algebra or pre-calc is you go plus c at the end to go up and down on the y-axis, and it goes in the same direction as that number. So plus 5 goes up by 5, minus 5 goes down by 5. You also taught that if you put the plus and minus inside the parentheses with the x, then it's a shift right or left opposite the direction of the number. So x plus 5 indicates a shift left by 5, whereas x minus 5 indicates the shift right by 5. Once you get a little more advanced, you start to come up with your own way of doing it so you don't have to remember two different rules for the shifting. For example, you could think of it as y minus c is equal to fx. Then it's opposite all the time. And that will also help you with things like the equation of a circle or an ellipse where the center is somewhere else, not at the origin. All right, that's shifting left and right. When you get a multiplication by a constant, that indicates some sort of compression or expansion, also known as a stretch. If you take a constant c times a function, then it indicates either an expansion vertically or a compression vertically. You either go away from y equals 0 or toward y equals 0. If c is greater than 1, then it goes away. If c is less than 1, it goes toward. Goes away, goes toward. And the opposite happens with the x-axis. If you put the constant c times x, when c is greater than 1, it actually compresses closer to x equals 0. And when c is less than 1, but still positive, it goes away from x equals 0. If that multiplication is by a negative number, then you separate out the negative one and you think of it as a reflection. Negative fx reflects across the y equals 0 line, the x-axis, and negative x reflects across the x equals 0 line, the y-axis. So those are the basic rules that you learned from algebra and pre-calc. Now we're going to do this problem here, where the reflection is not across either the x or y-axis, but across a different line. For these kinds of problems, my advice is always sketch a graph as you go. Don't just try to keep it in your head. Some people can do it, but it's just so much easier to have it on paper. You have the graph of y equals e to x, something like this. You have the line y equals 7 somewhere up here. And then you reflect it. And you end up with something like that. The rules that you know about reflecting is you reflect across the x-axis or the y-axis. If you reflect across the y-axis, you get something like this. And if you reflect across the x-axis, you get something like this. So you see that your answer is kind of like this one, except that it got shifted up. So you're thinking maybe I'm shifting before I flip, or I'm flipping before I shift. One or the other, or maybe both, will get me the answer I need. Maybe I can shift, then flip. Or maybe I can flip, then shift. Based on the picture, I figure it's got to be one or the other. Let's try this first. Shift and then flip. Currently, this is the final answer. So I know that like the distance here and the distance there are the same because it's a reflection. So I'm thinking maybe I shift it down first and then I flip. That means the last thing I did was a flip. So before the flip, I would be way down here somewhere. The last thing would be a flip. And the time before that is a shift. If I'm flipping from this bottom graph to the red graph on top, I should think about what happens with this line 7. That means before I flip, that 7 was a -7 down here. And I see that this distance here got shifted down the same way. So I have the same distance here. Therefore, here's how I see it. This point here got shifted down to here, the same way that this point here got shifted down to here. They must go parallel. The line 7 and the e to the x must have shifted down in the same way as each other. Well, I know this distance from 7 to -7 is a -14. So in terms of shifting, I know that it must have been a -14 vertically, and then a flip or reflection across the x-axis. I started with y equals e to the x. I go -14 vertically. So that gets me y is equal to e to the x -14. And then I flip vertically. Flipping vertically means multiplying the y by -1. So that gets me to y equals minus of all of this, which is 14 minus e to the x. All right, so that's the answer I got if I were shifting first and then flip. What if I try flipping first and then shift? Let's erase all of this. If I flip first, then I get something like this. And then I shift it up to there. Well, when I was flipping, I flipped this curve to that curve. Then what happens to the line y equals 7? It also got flipped down here to -7. This little distance here is the same as that little distance there, which is the same as that distance there. That tells me that if I were going back, if I were going from this line -7 up to this line +7, then at the same time, this point, which is this distance above the -7, will end up here, same distance above the 7. Therefore, I know that this shift, this last shift, has the same distance as the shift from -7 to 7, which is a total of +14. That means if I'm going to flip, then that means I flip, then +14 vertically. I start with y equals e to the x. I flip, I get y equals minus e to the x. And then I add 14 vertically, I get y equals negative e to the x plus 14, which is also 14 minus e to the x. Same answer as the other method. This is great. I managed to get the same answer both ways. As you remember from algebra and pre-calc, they don't necessarily work this way. When you do one transformation followed by a second, it's not necessarily the same as doing it the other way around. This time, it just sort of happened to work the same way, but it doesn't necessarily work the same way all the time. So for different kinds of problems, I might try different things, and they might find that only one of them works and the other doesn't. All right, hope that helps. Like, share, and subscribe for more contents. And thanks for watching. Bye.